Hello, fourth graders. Welcome to lesson 6.5, problem solving, finding equivalent fractions. Let's start out with, of course, a word problem. Anaya is planting a flower garden. The garden will have no more than 12 equal sections. 3/4 of the garden will have daisies. What other fractions could represent the part of the garden that will have daisies? Okay, so let's see. Anaya is planning a flower garden. The garden will have no more than 12 equal sections. Well, now, no more than 12 to me means it could be any number under 12 or 12 sections itself, but not 13 or more than that. So I could possibly have 6 sections. I could have 4 sections. 12 sections, maybe 9. I don't know. Let me read on here. The garden will have no more than 12 equal sections, equal parts. 3/4 of the garden will have daisies. Oh, well, that's an important fraction. If I had 9 parts, I don't know if I could have 3/4 of 9. Okay, we'll have daisies. What other fraction could represent the part of the garden that will have daisies? Okay, so I'm going to draw some gardens here. Okay, so this is my attempt at drawing 3 equal-sized gardens. I would use lined paper, however, I don't want the lines on the paper to mix you up with equal parts, so I would like to work on a blank slate, which means my rectangles are not going to be perfect. I'm trying to make them as equal as possible. Okay, so I'm going to start out, let's see, 3/4 of the garden will have daisies. Okay, the garden will have no more than 12 equal sections. Well, couldn't it have 4? I'm going to start with the first garden being 4 equal parts. Okay, so let's see, daisies. Daisies are yellow. So I'm going to say, you know what? I've got to go back. I don't like those fourths. That looks a little more equal to me. Sorry about that. Okay, so here's one garden in 4 equal sections, and each section is 1/4. Right? And 3/4 of this garden has daisies. So there's 3/4. I'm going to draw fourths again here. And let's see, could I cut those parts in half? So for every 1/4, I would make, just to show what I'm doing here, I'm going to change the color of this next line. Dark green. So I'm going to take the halves and make 2 parts out of, or take the fourths and make 2 parts out of each fourth. That would give me, well, 2 pieces for every 1/4. There's 4 parts. That is 8 equal parts, right? So what is equivalent to that? There's 2/8 or 1/4. 2 more eighths, or 2 fourths. See how they're equivalent here? 5 eighths, not equal to fourths. 6 eighths, that is equivalent to 3 fourths. What if, all right, so now I'm going to make those fourths again. And I'm going to make 2 parts out of each fourth again. That's 8 parts again, but I need to make another equivalent fraction. Oh, wait, what does it say? No more than 12 equal sections. Oh, darn. I'm going to erase those. Go back. Take the greens out of there. No more than 12 equal sections. Here I have 8 equal sections. Here I have 4 equal sections. Well, what if I make 12? How could I make this into 12 equal sections? There's 4 parts. I know that 4 times 3 is 12. Okay, let's see. How could I cut each one of these fourths into 3 parts? That would be really small. And maybe I'll go the other way with this. Hang on a second here. I'll do red this time. Okay. 3 equal parts. See? Each fourth is now in 3 equal parts. So that makes 12 equal parts. And I'm going to shade in. That's a whole fourth. 3/12 is 1/4. 6/12 is equal to 2/4. And 9/12 seems to be equal to 3/4. What other fractions could represent the part of the garden that will have daisies? So here are the gardens, 3 different ways. Each one of them, in each one of these gardens, 3/4 of the gardens are daisies. Only in the first one, there's only 4 sections. In the second one, there's 8 sections. So 6 eighths is equivalent to 3/4. And in the third one, there's 12 sections because every fourth was cut into 3 smaller pieces. And 3/4 is equivalent to 9/12. So let me show you that over here. 3/4 equals 6 eighths. And what we did was, we'll do green here, multiplied the numerator and the denominator by 2. And then we also had 3/4 equal 9/12. This time, multiplying the numerator by 3 and the denominator by 3. So we made our equivalent fractions. All right, let's move on. Okay. 2 friends are knitting scarves. Each scarf has 3 rectangles, and 2/3 of the rectangles have stripes. If the friends are making 10 scarves, how many rectangles do they need? How many rectangles will have stripes? Ooh, wow. Okay, let's see. Two friends are knitting scarves. Okay, each scarf has 3 rectangles, and 2/3 of the rectangles have stripes. If the friends are making 10 scarves, they didn't say 10 scarves each, so they must be making 10 scarves altogether. How many rectangles do they need? How many rectangles will have stripes? How many rectangles do they need? How many? Okay, so I want to draw a picture of this, just one scarf right now. Let's see. Here is a long scarf, right? Each scarf has 3 rectangles. Okay, so maybe it's like quilts, like a quilt on a blanket. Instead of squares, it's rectangles. Does that look like 3 equal pieces? Hang on a second. Oh, goodness. Okay. There's my scarf. It's a little fatter this time. And I've got 3 rectangles. Equal parts, right? And it says 2/3 have stripes. 2/3 of the rectangles. Well, if there's 3 rectangles, 2/3 would be 2 out of the 3. So let's get some stripes in here. Let's make it pretty. Oh, purple. Let's make the end ones stripes. 2/3. And let me see, if I was making a design, I wouldn't put 2 and then the last one blank. I might have the 2 end ones striped. I don't know, just me. I don't knit, so. Or sew. I don't even sew buttons. I take them to the dry cleaners. Anyways, okay, so here's my scarf. 2/3 of it is striped. Maybe we'll just add a little color. That middle part's just solid. There. Kind of looks like a Band-Aid, but it's a scarf. Okay, there's a scarf. 2/3 of it is striped, because 2 out of the 3 equal parts is striped. They don't look so equal anymore. Oh well, they are. Each one of those rectangles is the same size. Okay, so let's see. If the friends are making 10 of these, 10 scarves, how many rectangles do they need? Well, let me write a fraction. 2 out of the 3 rectangles needed for 1 scarf. 2 out of the 3 are striped. 1 is not striped. So if they made 10 scarves, that would mean they would need 10 groups of 3 rectangles, or 30 rectangles. And they would also need, for 10 groups of 2 striped rectangles to be there, right? So whatever, if they're going to make 10 of these, they need to multiply the striped rectangles by 10 and multiply the total rectangles by 10. So that would mean 20 out of the 30 rectangles, just like 2 out of 3, would be striped. So, stripes, striped rectangles. Always good to have labels. Total rectangles. There you go. We should probably include a label for the times 10. Scarves and scarves. Okay. Okay, in this next part, I'm going to get you started on a problem that you will finish during class, either tomorrow or Thursday. If you're in Miss Kennedy's, you'll do it tomorrow. If you're in Miss Brewer's, you'll do it on Thursday. I want you to draw 3 number lines, like I have here, leaving plenty of space in between the 3 of them because you'll be doing some drawing. In the first number line, I want you to show where 1/2 is. So here's 0, here's 1. Show me where 1/2 lies on that number line. On the next number line, here's 0, here's 1. I want you to show me where 1/5, 2/5, 3/5, and 4/5 lie on this number line. So you will divide the number line into 5 equal parts. You won't put 5 lines, you'll put 4 lines, and that will make 5 equal parts. Remember, this is 5/5 as well. And this is 2/2. Okay, and on the last one, here's 0. I want you to, this is 1, I have to write it above. I want you to divide this number line and label where all of the tenths are. And 1 would be 10/10. So you should have 9 lines in here. Make it as even as possible. And when you're done, I want you to determine, based on the number line, if we have some fractions on the different number lines that are in the same place. So in other words, are there tenths that are equal to any halves? Are there fifths that are equal to any tenths? That's what I would like you to identify. That is your homework. Take a lot of time to make these nice and neatly, please.